Hello students, today I will start with a new topic, that is a basic concept on pH and universal indicator. So let's start. We know water is slightly ionized into H plus and OH minus ions. So pure water, the concentrations of H plus ions and the OH minus ions are equal. Thus we can say pure water dissociates to yield H plus and OH minus ions which are equal in quantity. Thus we can say that they are neither acidic nor basic. Okay students? Now from Arrhenius definition we know that acids are those compounds or those substances which in aqueous solution, that is in water, yields H plus ions. Thus acid increases the H plus count which exceeds the OH minus count. Thus in aqueous solution, that is acid plus pure water, the H plus count is more than the OH minus count. Similarly, from the Arrhenius definition, we can get that base in aqueous solution yields OH minus ions. That is, the base increases the OH minus count which exceeds the H plus count in water. Okay. Now, thus we can state that in basic solutions, that is base plus pure water, the OH minus count is more than the H plus count. So we get here a very clear, basic and simple conclusion that what I have said earlier, that H2O dissociates into H plus and OH minus which are equal in quantity. But as we add acids into these, into pure water, the H plus count increases. So in case of acid, the H plus increases. So in H plus increases, and when we add base, the OH minus count increases. So here the H plus count is less than the OH minus count. So this can be stated simply here. In acidic solution the H plus is more, and in basic solution H plus ion count is less. But from both of these situations we get a normal conclusion, a very simple conclusion, that in both cases there is H plus ion present, more or less, but the H plus ion is obviously present in both kind of solutions. On the basis of this concept that the H plus is present in both acidic and basic solutions, a scientist, a renowned scientist, Sorensen, in the year 1909 devised a scale which is called the pH scale to measure or indicate the strength of acid solutions as well as basic solutions using the H plus concentration count. Okay students, here is a note, here is a point, that Sorensen linked the H plus ion concentration of acid and basic solutions to the simple numbers, very simple numbers, 0 to 14. Okay students, here we should remind this thing, this is very important, that pH of any kind of solutions, whether it is acidic or basic, is inversely proportional. This is a proportion sign, and it is inversely proportional to what? Concentration of the H plus ion. This is very important. Okay students, thus from this we can conclude acidic solutions which have a high yield of H plus ions have a low pH value, and the basic solutions which yield which have a low H plus concentration have high pH value, as these are inversely related. So students, Sorensen linked the H plus ion concentrations of acid and bases to simple numbers 0 to 14. So pH is a pure numeric value from 0 to 14 and it has no units. Okay students? Now we have some basic rules of pH. So what are the basic rules of pH? For neutral substances, the pH is marked as equal to 7. For example, pure water, which is neither acidic nor basic, has the pH value equals to 7. Similarly, sugar solutions, NaCl solutions, which does not increase or decrease the H plus concentration, all has the pH value equal to 7. Now the next rule for pH is for acidic solutions. For acidic solutions, pH is always less than 7, which is ranging from 0 and below 7. An important note is more acidic a solution, lower will be the pH. That is, more acidic a solution is, its pH value will be lower and lower from 7. For example, here we can get a solution of pH 1. Suppose a solution of pH 1 is more acidic than a solution of pH 4. Generally, it is considered that solutions with pH values 0, 1, 2 and 3 are considered as strong acids, and solutions with pH value 4, 5 and 6 are considered as weak acids. It is very important students, it is very important. Now the next topic and the next rule of pH is for the basic solutions pH is more than 7. So it is what is it? It is more than 7 and up to 14. Generally, for basic solutions with pH values 8, 9 and 10, these type of bases are considered as weak bases or weak alkalis. Here we can use the two names, bases or alkalis. Okay students? And solutions with pH value 11, 12, 13 and 14 are very strong bases or alkalis. So all these values, that is 8, 9, 10, 11, 12, 13, 14, all are more than 7. Obviously all these are bases. Here is a classification between bases, that is the weak base and strong base at such specific pH values. So here students, a common pH scale having the pH values from 0 to 14 is given in this figure. From here we can get that in this scale the pH value 7 is for the neutral solution, okay, and values less than 7, that is 0, 1, 2, 3, 4, 5 and 6, all these indicates acidic solution. Values more than 7, that is the 8, 9, 10, 11, 12, 13, 14, all these indicates the basic solution. From those given considerations, we can here state as that the values, pH values having 4, 5 and 6 are weak acid, and pH values with 0, 1, 2, 3 are strong acids. Similarly, for base, here we get the pH values 8, 9 and 10 all are weak bases or weak alkalis, and the pH values 11, 12, 13, 14 are strong bases or strong alkalis. Okay students, so as we go left towards the left hand side from this neutral point, it indicates that the solution, that in the solution the H plus ion concentration is increasing, that is it is acidic solution, and as we go towards the right hand side of this scale from the neutral point, here we get that this solution has an increasing rate of the OH minus concentration. So here students, let's get started with the new topic, that is the universal indicator. So what is a universal indicator? Before going for universal indicator, we should know what is a common indicator. A common indicator like litmus, as you all have heard about the name litmus or litmus papers, it just only indicates whether a substance is acid or base. It just indicates whether it's acid or base. It does not specify the relative strengths, whether it is more acidic or more basic. It just indicates whether it's acid or base. For example, if we take sulfuric acid and vinegar, both of these compounds are acid. Litmus paper indicates both are acidic, but which one is stronger acid? It cannot be specified by common indicator like the litmus paper. To obtain such relative strengths, that is how acidic or how basic a solution is, we need a universal indicator. This is the utility of universal indicator, to obtain the measurement of relative strength of acidity or basicity of a compound. So what's the definition for universal indicator? Universal indicator is a mixture of many different indicators or dyes which gives different pH values of the entire pH scale. Universal indicator may be a solution or a strip of paper which looks like this. Okay, generally this strip of paper is used in school laboratories. When this strip of paper is dipped in acidic or a basic solution, okay students, then this strip of paper changes its color, and the color produced by this universal indicator strip of paper at various pH values is shown in this chart. From this chart, we get that if the strip of paper gets this color, then it has a pH value of 1. This is very deep red. It's comparatively lighter, then the pH value is 2. Comparatively lighter red, then it is pH value 3. When the strip of paper gets the color orange, as you can all see here, it is orange color at the pH value 4. Thus, after dipping the strip of universal indicator, we have to match the color of this color with this given chart of color. After matching with this chart, we can get to know what is the actual pH of the given solution. Okay students? In this way, we can use a universal indicator in laboratories to get the exact value of the pH of a given solution. So students, here I am up with a new point, that is the importance of pH in everyday life. There are many importances of pH in everyday life. Among all those importances, the two most important points are pH in our digestive system. Okay, our stomach produces HCl. We all know about this. Our stomach produces HCl, and this dilute HCl helps in digesting our food without harming the stomach. Sometimes excess of acids are produced in stomach due to various reasons. One of these reasons is overeating. Okay, this excess acid in the stomach causes indigestion, resulting in pains, irritations. Now the prevention. To get rid of these, we take bases called the antacids. Okay, meaning anti-acids. groups of mild bases which neutralizes the excess acid present in the stomach, and all these mild bases are called antacids, and very common antacids which are used for neutralizing the excess acid formed in the stomach are magnesium hydroxide MgOH whole 2, which is called milk of magnesia, and the second one is sodium hydrogen carbonate NaHCO3, which is called the baking soda. Another very important use of pH in our everyday life is we can see the pH change which causes the tooth decay. When we eat sugar containing food like sweet foods, carbohydrate containing foods, bacteria present in our mouth break down the sugar to form acids, mostly the lactic acid. This acid, when the pH value of the mouth falls below 5.5 due to formation of such acids, tooth decay starts. Such acids are strong enough to attack the enamel of our teeth and corrode it. So, preventive measures to get rid of such problems is the best way to prevent is to clean the mouth after having meal, especially rinsing our mouth with lots of clean water. Another best preventive measure is brushing our teeth with toothpaste, because toothpaste has the pH value 8.0, which is a weak base and which is well enough to neutralize this acidic reaction occurring in our mouth, which causes the tooth decay by corroding the enamel. Okay students, this much for pH. I hope you all have got a clear idea about pH and its utilities. So students, this much for today. This is what I described about the pH and the universal indicator. If this video has been helpful to all of you, then please like the video, share the video to all of your friends so that they also get benefited with it. Subscribe my channel and press the bell icon. Thank you.